Alright, hello friends. So in this video we'll be discussing about the standard deviation and the variance. So let's get started. Let's first know what is variance. So let us suppose an example where we have person A, B, C and D, and the weights are respectively A has the weight of 40 kgs, whereas B have 60 and C have 50, whereas D have 70 kgs of weight. So let me just write it over here: 40, 60, 50 and 70. So these are the weights of A, B, C, D, and the weights are as given over here. So let us first find the mean. What is mean? Mean is just the average. Let us denote it by x bar. So let us find the mean. 40 plus 60 plus 50 plus 70 divided by, we have 4, so we'll take it over here as 4. So we are getting the mean as 55. Alright, so now we have the mean. So let us draw a line over here. So let's call this x bar. It is at 55. So what we need to do is that now we need to find the distance of each and every point over here that is away from the mean. So basically we need to find the distance over here. So how much distance is the point A away from the mean? And similarly with B and C and D. So we need to find the difference in order to know how much the points are away. We'll be finding the distance. So basically variance is similar. So let us now understand what is variance. Variance is the average of the distances from the mean to the different points. So let us write this. The point A is 40 minus the mean is 55. Now if we do this, we'll be getting the negative value, negative 15. So now in order to avoid the negative values, because the negative values get cancelled out with the further values, and that will affect the overall result what we'll be getting. So in order to avoid that, what we do is that we'll add a square. So let me just do 60 minus 55 whole square. As you can see here, next we have 50 plus 50 minus 55 whole square plus we have 70 minus 55 whole square divided by 4. Alright, so now we got the variance value as 125. As you can see, as we have squared the numbers over here in order to avoid the negative values, so the overall the value which we are getting is quite high. As you can see, 125 is quite high. So in order that, so that's the reason it's not useful for us. So that is the reason we don't use variance more often. We use standard deviation. Now what is standard deviation? Standard deviation is denoted by sigma, which is equals to just the square root of variance. Now sigma is equals to square root of variance. So we got the variance over here as 125. So let me just substitute it over here. So we'll be getting the value of standard deviation as level 0.18. So this is how we'll calculate the standard deviation of any particular data. So now, what is the use of standard deviation? Why we are calculating the standard deviation? The very first thing is to know how the values are spread out, to know how the values are close to the mean. So let me just give an example. Alright, so basically understand this thing that the lowest standard deviation indicates that the values are closer to the mean, whereas the highest standard deviation indicates that the values are far away from the mean. Now this is one use, and let me just rub this out. Alright, so We also use standard deviation in order to know if the given data is normally distributed or not. For example, any given data, if it's normally distributed, it will be in the shape of bell. So this is also called as bell curve. This is how a normal distributed data looks like. So how we can say if the data is normally distributed? Let us say this is mean, the line which I just draw, this is the mean. So from the mean, one standard deviation away plus 1 and one standard deviation behind the mean. In this particular area, we have 68% of the total data. Now from here, x bar, 2 standard deviations away and 2 standard deviation backwards. Now in this entire range, the whole entire range over here, we have 95% of the data. Now if we go further away, plus 3 standard deviations and minus 3 standard deviations, now in this all curve we have 99.7% of the data. So this is what is called as 68 and 95 and 99.7 rule. Basically, using standard deviation, this is how we can say if the data is normally distributed or not. So when we find the standard deviation, we have a standard way of saying if the data is normally distributed or not. So this is the use of standard deviation. We won't be using variance more often because we get very higher values. So for example, if we are calculating anything in kilometers, so as variance is kilometer, variance is square, so we'll be getting the result in kilometer square. We don't need that. We need the result to be in kilometer as well. For that, we'll be adding a square root. That becomes the standard deviation. Now we'll be getting the results in kilometer itself. And this is an example of standard deviation, how to calculate it, and what are the use of standard deviation. Thank you very much. If this video helped you out, please like, subscribe and share. If you like this video, make sure you like, subscribe and share this video. Thank you very much.